For those of you who are here, if you are able to turn on your cameras, I'd appreciate it. It's always helpful to see some faces, and it's useful for you to see each other's faces as well. I do have some material prepared in terms of web scraping for today. So I was thinking that we can start with those, but I'll try to give some time at the end for homework questions as well. And I answered a bunch of questions on Piazza this morning too. So what I wanted to go through today is actually what we covered in the last two videos. So we'll work through the same exercise today, and then what you're going to be working on in the workshop tomorrow, we'll be scraping from a different web page. So in the workshop tomorrow, you'll be scraping from the University of Edinburgh's art collection webpage. So we'll be getting data on those. But for today, we'll continue our analysis on the First Minister's speeches. So let me go ahead and share my screen. I'm just curious, when I share this, do you guys see this chat window here too, or is that not visible to you? Okay. All right, it's just the chat that you are writing in. All right. So let's do this. So if you go to RStudio Cloud, there's a new code along project called First Minister COVID-19 speeches. That's code along 06. So if you want to follow along, you can go ahead and do that. And I'm going to start with the first one here. So a little bit about the background for this. This is actually something I've been working on since the summer. I mean, not the teaching part of it, but the getting the data, because I'm very impressed actually by Nicola Sturgeon's speeches that she gives every day. She talks like very almost scientifically in a way not many world leaders do. So I've been doing this analysis of the text and comparing her speeches to the speeches from 10 Downing Street. So sometimes that's Boris Johnson and sometimes not. So I figured at the end of the semester, when we do text analysis, we can actually dive into the text. But for now, we're going to focus on the web scraping aspect of it. So what we're going to start with is the speech from October 26, which is actually, I think she, after that, gave two more speeches. Like she talks almost daily on this matter. I don't know if, has any of you seen this briefing? Maybe let me know in the chat. Has anyone watched the briefing? Yeah, so bits of it on Twitter. So I think that every single day she starts with, good afternoon, here are the numbers. And then she's also always very clear about like, it's by this measure that we're counting them today. And she always says that this is a hard time, my condolences, like very methodical way of speaking through the whole thing. And then at the end, there's a Q&A component, and I find the Q&A very funny because the way I think journalists here ask questions are a little bit different than they do in the US and a little bit different than they do in Turkey as well, which are other news I follow. So oftentimes journalists will ask things like this: First Minister, have you failed in your duty to protect this nation? Like just really, really like hyperbolic statements that I find funny. But anyway, what we're going to do is we're going to get the speeches, and then later on in the semester, we can do a text analysis on them to see if we can actually see what emotions are in the speeches. That's what we'll do later. So here's a web page that we want to scrape from. And one of the things that we talked about in the videos is that we want to, wait, can you see the sharing the screen? Is it showing or no? Let's try this again. What about now? Can you see it? Okay. All right. So what we're going to do is we're going to use the Selector Gadget to select bits of the web page. So there was a question on Piazza earlier this week that asked, do we need to install the Selector Gadget? And my answer is yeah, I think it would be really good if you did, because otherwise any other way of doing web scraping, there are other ways, but it's going to be incredibly more tedious to do so. So we're trying to give you kind of the more user-friendly way of doing web scraping. So what we're going to do is the process of web scraping often goes like this. So we start with what we want to scrape the data from. So I'm going to set a URL, and this is simply the character string that I'm working with. Okay, so that's just a character string that I am trying, the URL of the website that I'm trying to scrape data from. And our first thing always is to get the entire website source code. So actually, when we're doing web scraping, we're only getting data from the website once and then storing it as an R object, and then kind of parsing that object and extracting bits and bits that are useful to us from it. So it's not like with every line of code we run, we're sending code to the website. We're only sending code once to grab the source of the website as a whole. When I say source of the website, what I mean is that if this is what you're seeing as the website, if you go to view and then developer, this is in Chrome, but it will be similar in other browsers. There are some things you can do. So one of the things you can do is to view the source of the web page. And I mean, this looks completely like gibberish, but we can try to see if I look on the main web page, maybe for this character string, which is the title, right? I'm going to copy that and I'm going to try to find that in this web page. So you can see, for example, that that's stored as a headline somewhere, right? So on the web page source code, we can see bits and pieces that are visible to the human eye, but there's a lot more on the web page. And some of that is content and how the content is styled, and some of it is other hidden stuff. Like oftentimes web pages collect data on you, they collect analytics on you, they try to figure out how many people have clicked on things. So there's going to be code that pertains to that on the back end as well. So this is the source code. So the source code is usually only HTML, and then it will link to CSS code, which is the style file. And this looks insane, as you can see, but we could kind of make some words out of it. They try to make these like all into this like really condensed text, but you can see things like X large here, for example, like that's probably for styling larger text. So the CSS code tends to be often linked from the source code that you see, and this is usually just the HTML or sometimes JavaScript. So what we want to do first is to grab the source code. Does anybody remember? And also remember, we use the tidyverse package, obviously, and the package we use for scraping data is rvest, and then I'm going to do some stuff with date, so that's lubridate. So the new package we're working with this week is the rvest package. And the one other new thing we're doing this week is we're using R script. So if you've seen the videos, you've heard me talk about this workflow idea, and this might be the first time you're actually seeing it in person, except for, I guess, the application exercise, the application exercise video. So instead of using an R Markdown document like for the analysis, we're using an R script where we only have the code and some comments about our code, but not our prose. And the way you can run code from your R script, you have a few options. You can put your cursor on a particular line and hit run. You can highlight multiple lines and hit run, or you can highlight multiple lines and do command return or command enter, for example, or you can put your cursor at the end of a line and do command enter. So any of these are possible options for running your code. I often just set my cursor, so right now it's blinking on line 10, and then do command enter to run the code from there. So the first thing we want to do is to read the page. Does anybody remember what function we use to read the website source code? Read HTML, exactly. It's just like the other read something functions that we have seen. So here is read HTML, and I'm going to store the result of that as speech page, okay? And you can see in my environment that it is a list of 2 elements. And if I take a look at it, I can start seeing something about it. It's an XML document, it says, but as we said in the videos, we're not really going to try to inspect that object ourselves. We're going to try to parse that object using rvest functions. So the first thing we want to get out is the title. And the way I've structured these scripts for you is they're kind of fill in the blanks. So we're not expecting you to write the entire code from scratch, but let's go through and hit on some useful pieces to kind of walk you through the exercise. So let's start with the title. Okay, so go back to your web page. And so if you want to follow along, you have the link on the RStudio Cloud project as well, but you can go to this link. And if you use your Selector Gadget, we're trying to basically select the title. And then once I have the title selected, so you can see in the bottom corner of my screen that like the only thing selected is the title. And I know that that's the only thing that's selected because I'm only seeing the number 1 here. And the tag for that seems to be this character string. So I would copy this character string and then basically paste it in here. Okay. I had already given you that. So if I want to get that component, that node out, the function I use is HTML node. Okay. So let's go ahead and run only those 2 lines. So starting with the speech page and then extracting out the node. It says H1 class, article, header, title. Okay. Usually what we want to get out of this is the text. So I'll say, give me the text from it. And in fact, that gets me what I want. So usually these 2 functions go hand in hand, except we're going to give one example at the end where we don't want the text itself that's visible to the human eye, but the link underneath it. Any questions about what I've done here? Because that's a pattern we're going to repeat over and over. So I'd rather answer that question now. Okay. So when I'm working through an R script, usually what I do is I will, run pieces of code, have them print out on my console, and then ultimately, if I like what I see and I want to store it, then I would store it to an object. So I'm going to save that as title. And now I can see that show up as title in my environment as well. So I know that that's an object that's available to me for the rest of the analysis. Now let's take a look at the date. So I'm going to go back to the web page. I'm going to clear my selection. And this time I'm going to try to select the date. So I click on the date and now more things are selected as well. In fact, it looks like 4 elements are selected. It says delivered by First Minister Nicola Sturgeon. I'm going to unselect that. And now we're down to 1. So it looks like these other 3 things had some similar styling. So this crazy character string is what gives me the date, it seems like. So I'm going to copy that from what the selector identified. And let's go ahead and try running these 3. And in fact, it gives me the text string exactly as it's displayed on the web page. And one other thing we might want to do, because we're going to do an analysis of these data ultimately. So I don't want my dates as character strings, actually. I would rather have my dates stored as date objects that are recognizes as date objects and understands its components to be year, month, and day. So I'm going to use the DMY function from the Lubridate package. So I know we've mentioned the Lubridate package before, but I don't think we've talked about these particular functions. And what they do is they take a character string. You as the human need to help them a bit. So you need to tell them which order the components are in. So in this case, it's 26 is the day, October is the month, and 2020 is the year. That's why we said DMY. And it does what needs to happen for parsing that text and converts it to a date that R can recognize. So to the human eye, these 2 pieces of information are the same, 26 Oct 2020 or 2020-10-26, but for R, one is more meaningful than the other because this string here actually is a date object now that it knows what to do with. So I'm going to store that as a date. Any questions about the date? All right. Now I'm going to show you one other thing that you can do with the Selector Gadget. This is especially helpful for collaboration. So this might be something helpful for your labs tomorrow. Let's say that one of your teammates identified a particular element. Give me 1 second. So let's say that one of your teammates identified a particular element and you want to just kind of check to see if that's correct. You can get that tag that that somebody else had identified and put in the code. Like, let's say you pulled from GitHub and you got this information. You can actually use the selector gadget the other way around as well. You can simply pop that in there and hit enter and then see what it corresponds to. So it really works both ways, which is helpful for checking somebody else's work. So here I've identified that for you. And what is the pattern we're going to use for the two functions that we're going to use for getting the text of the location out, which for many of the speeches is the St. Andrew's House. What function should I use on line 28? Yep, HTML node. And then on line 29, yep, HTML text. So let's go ahead and give that a try. In fact, we get what we want. And finally, let's do the speech. I know that the pattern will be the same. Sorry, the abstract, but let's go back to the web page, clear, and select the abstract. That selected too many things. Let's unselect these. Here we go. I think now we only have one thing selected. And sometimes these tags make sense. Sometimes they don't. But like to me, when I say first para, it probably says first paragraph. That kind of like makes sense for what that text is. Let's give that a try. Okay, as you can see, I'm always like trying out my code. And then if I'm happy with it, I say I'll assign it to that. And then finally, let's get the text. So I'm going to clear this out. And the text is basically this whole thing under here. So I have no idea how many paragraphs it is, but it looks like, I don't think I want this. Here we go. Preamble P is maybe what I want. Let's do HTML node and HTML text. Now, one thing I'm going to do here, let me show you what this gets us. You can see that this only grabbed the first paragraph. Why might that be? How would I fix my code so it grabs the whole thing? Nodes, exactly. So I would want that to be nodes. So now I actually have something. But the problem with this sort of data is that it actually is not a single element anymore, right? So I have basically a pretty long vector that I have. So 47 paragraphs, it seems like. Yeah, 47 paragraphs. So then what I really want to do is I want to be able to store all of this in a single cell. So I'm going to convert them to a list, okay? And we'll talk about this list bit in a little bit. So that's the bit I'll give away to you for now. And ultimately, we can put everything together in a tibble. So this is the title, the name of the column, and these are the various objects that we had saved along the way. And here is basically a single row of the October 26th speech. Okay. Now, if I want to get October 23, what I need to do is go back and figure out the URL for that. Let's see, I wonder if it's just this. Yeah. So here's the URL for October 23. So I'm going to give that, just pop that in here. And what I have copied and pasted for you is the same thing. So the same code that we developed up top is basically here, except this time I am applying to the October 23rd URL instead of the October 26th. And what we're ultimately going to do is something like the following. We're going to get data from each of the dates, and then we're going to combine them together. So each date, each speech gives me a row of a data frame. And if I want to combine them all together, what I want to do is to bind these rows together. So there are two functions in our bind rows or bind columns for bringing data frames together. In this case, because each one of our speeches results in a row, I'm going to bind the rows together. So I can, if for just these 2 dates, my COVID speeches object is a data frame where each row is a speech from one of the days. Our goal is to do this for all of the speeches, okay? So the thing that we had to do here was to copy and paste our code. And that's basically part of what we're learning to avoid this week is how do we avoid copy and pasting our code in this way? So what we're going to do instead is we're going to write a function for doing this. So from like a data perspective, what we're learning as a new kind of skill today is getting data off the web. But from a kind of a programming perspective, the new thing we're learning this week is writing functions, okay? So first we have developed our code, and this is always the process for writing functions. It may be for an entirely different purpose, but the way we write functions is first you want to develop the code that goes into the function, and then you wrap it around to say, okay, I actually want this to be a function, all right? And we basically wrap it in these curly braces. And then we think about what are the inputs into my function. So the code that I developed was basically what I had here, right? So I'm going to go ahead and grab this code that I copied one more time in order to kind of do the same thing for October 23rd. And I'm going to paste this here, and then let's take a look at what is going on in this code, okay? The first thing we had done was to set the URL of the page that we want to scrape data from. That is not something we're going to want to do inside our function. That's basically what we want to pass to our function as an input so that the function can go to that URL and do what it needs to do. So we don't want to hard code a particular date's URL. We instead want to be able to give that as a variable to the function. So I'm going to get rid of this, and I'll say whenever I run the function, I want to give it the URL that we want to run the function on. However, once it has the URL, the rest of the code actually can stay exactly as is, right? Because the way we wrote our code before is that it took a URL and then it read the page from that URL and saved it as an object. And then it used that object throughout to extract certain components. And then ultimately it put things together in a tibble. The one other thing, well, the tags, right. So we're assuming that the tags are always the same. So we've tested it on 2. And what you might find is you're going to test it on maybe a handful of them. And then you're going to assume that they are right. And then you apply your function to all of the pages. And maybe when you do apply it to all of the pages, based on the resulting data, you might find out that some things actually did not work, in which case you would go back and enhance your function. But there's no really way of finding out without trying it on all of the pages, basically. So as a result, we had created a tibble and saved it as an object, right? And that object was specific to that day where we were scraping the data from. So we obviously don't want to do that when we're writing a more generic function. Instead, what we want our function to do is to spit out that tibble. So that's going to be the output. So our function has one input, which is the URL for the page, and has one output, which is a tibble, which we know is a 1x6 object, 1 row for the day, and then 6 columns for the particular features of the speech that we are grabbing. Does that make sense? So let's go ahead and run this whole thing. And I'd like to note that when I run this whole thing, I get nothing out, right? Because right now, all I have done is I have created a new function in R that I can see is, so scrape speech. So it's not even, it's not under data or it's not under values in my environment, it's under function. So it's a custom function that I've written, but it doesn't give anything to me just yet because we haven't given any inputs to that function, okay? So we're not applying the function, we're just now writing the function. Now, that being said, if you had a syntax error in your function, so let's make an error and let's go ahead and run the whole thing. Obviously, then it gives you some stuff. Then it gives you some errors along the way because you have a syntax error. But if all is well with your function, it's not going to print out anything for you. It simply saves it for you so that you can then apply it. So how might we apply our function? So now I'm going to open the third file here where I'm simply applying things. And what I wanted to show you is one new thing here where you can see that my function is in this file called O2 scrape speech. So I can clear my entire environment just so you can see there's nothing available to me in my environment right now. And I'll load my packages that I need, and then I'm going to source that file. What this basically does is it says, open that file and run the whole code inside of it. Okay, it's doing nothing more fancy than that. It basically said, run all the code that's inside of that file. And now you can see that in my environment is populated with that function. Let's try it one more time. So if I source the file where I define the function, then it would basically show up here. It doesn't just have to be a function. I could put in this file something like x is 2, for example. So I clear the file, the environment with a little broom. And then I source this function, source this file, then I would get both the x and the function that I have. So it basically runs the whole code. All right, let's get rid of this thing we don't need and clear things and load our packages and source our function. Here is the URL for October 26. If I want to apply the function that I wrote to URL for October 26, it basically spits out that tibble for me. So this is exactly the thing that we wrote before. In fact, I can save it as an object. Oh, sorry. There we go. I can save it as an object called speech 26 October. So the result of my function is saved as an object. This is very similar to what we've done in the past where we've saved the median of a data set as an object or something like that. And similarly, I can do the same thing for October 23. I can just take a look at the result, or I can save my result. And if I save both of my results, I can bind those two rows together to make a data frame with two rows this time. Okay? So what I've done so far is simply I've repeated what I did in the first file where I was going through the code manually one by one, except doing so using a function. So any questions about writing functions? All right. The last stage is going to be about applying this function over. What if I want to do a list of the URL? So that's what we're going to do next, Ismail. So we want to now actually not by manually figure out the URLs for each of these pages, but instead we want to get all of the URLs in one place so we can apply that function programmatically to all of them, because we have made our workflow better by writing a function, but we're still not really that good, because if I'm going to have to do this one by one for every single day that Nicola Sturgeon spoke, we're going to be here for a while. So we don't want to do that. So the last thing that we're going to learn about is, now that you have a function, how do we actually use this function across a list of URLs? Okay, so I'm going to clear my environment again, just so I can show you what's happening. Load the packages I need. And once again, source the function as well. It's the same function that we wrote before. So let's take a look at this page where we have links to all of the speeches. Okay. I'm just copying that URL. So this is the fourth file for those of you following along. So here we go. And here are the links to all of the speeches. And what really we want is not the titles, right? But the information underneath these. So I'm going to go ahead and copy this text for a second, okay? And I'm going to go and show you the source code for this page. And in this page, in the source code, I'm going to look for that text. You can see that there's a list called collections list. And in here is links to all of the speeches, right? And here are the titles of the speeches. This is the text that we've been looking at. But we can see over here that under a tag called href are also the links to the speeches, right? So we have the URLs in here, but they're not the text from the nodes, but they are in a particular attribute called href. So that stands for hyperlink reference, okay? That's always the case with HTML code. So I said, in order to do web scraping in the context of this course, we don't expect you to know HTML. We don't really expect you to be able to make web pages, but there are a couple things about how web pages are put together that you are going to need to know if you want to scrape data from a web page. So for our purposes, really what we need to know is that links, the URLs, are under an attribute called href, okay? And that's what we're going to leverage here. So let's go back to RStudio Cloud and let's take a look. I'm gonna read from that page. So that's this page over here, read the source code for that page. And then once I've read the source code, I want to go ahead and grab the nodes for the links to the speeches. So let's try to figure out what those are. I'll use the Selector Gadget again. And let's try to unselect some things we don't want. I think that gives me everything. Yeah, so these are all of the speeches, and note that some of them are about other stuff because this is pre-COVID. And then once we get to 2020, she's been busy. Okay, let's go ahead and copy this. And I'm using HTML nodes, not node, because it's a list of them. And let's go ahead and take a look at what this gets me. So here are basically the nodes that I was able to extract out. And what I want from here is not the text, but instead the URL. So if I use my usual workflow or my usual formula of then piping this into text, I get the titles, but I know that that's not what I want. Instead, I want that href attribute. So for that, I use a different function called attr. So for attribute, and I'm going to get the href attribute from them. So this is the one bit so far where I'm using additional HTML knowledge, and one that you should be familiar with if you're ever doing web scraping. So now I have that information out. Does this look like a URL to anybody? In a way it does, but in a way it doesn't. Usually, how does a URL start? It's usually like HTTPS, www. We don't have that information here. And also, this is all of the URLs, right? We have something about European Union, whatever. I don't want all of these. I only want the COVID speeches. So the first thing I'm going to do is I'm going to say, here are a bunch of text strings. And thankfully, this is so thankful, like this could be not like this, but whoever designed this web page made the links to all of the COVID-19 ones actually have the character string COVID-19 in it. They could have not, and then we wouldn't have just easy a time. But because they did so, we're able to subset the data for character strings that have the character string COVID-19 in it. And then the last thing I'm going to do is say, well, these are only kind of the partial links in order for me to be able to go to a web page. So if I copy this and paste it into my URL, it can't find it. but we know that these are accessible from the ScotGov webpage. So if I actually put the kind of the main bit, so the kind of the home page for ScotGov at the beginning, then I can actually get to the speeches. And this I had to do some digging around to figure out what the pattern is. So if you're scraping a web page that you know that you're familiar with, you may need to do a little bit of kind of figuring out yourself as well. So what href stands for is hyperlink reference, and hyperlink is basically link to a web page or link to anything really. Like you can have hyperlinks in a Word document too, where you would be linking out to a web page. And in HTML, we basically store the links under that attribute, the href attribute. So here what we're doing is we're using this thing we mentioned once in class, but haven't really used a whole lot, which is that we're using a pipe, but we're saying whatever is the result of what comes before it, I don't want that to be used as the first argument in my pipeline. I want it to be used as the second argument. So the first argument is going to be this kind of homepage link. And then after that, I want to append all of those with the partial links that I had grabbed from the web page. So now I actually have a list of all of my URLs. So there, any questions about here? So a few things new that we did is we got the attributes out as opposed to the text. And then we also use this dot operator to place what we got from a pipeline, not as the first argument, but elsewhere in our pipeline. STRC basically concatenates, so it concatenates strings together. So it joins multiple strings into a single string. And why we subset? Because before we subset it, we were getting links to all of the speeches the First Minister has given, and some of them have nothing to do with COVID. Like one of them is from 2016, for example. When you are, why might I get an argument pattern missing with no default to str subset? So let's take a look at str subset. Pattern is the second argument and string is the first argument, right? You might get something like that if you maybe forgot the pipe before it, so you didn't pass anything into it. Might that be the reason? Right. So we're passing what we got before it into the subset. So we can subset it for just the COVID-19 speeches. That's what Crystal was asking. And then Ismail was asking, then what are we doing with STRC? Then we're basically creating longer character strings by putting two components together. And so now what we're going to do is we have a list of our URLs. And we have a function available to us to this is the function that we wrote, get data out of every single URL. So what we're going to do next is we're going to say we want to map over the list of URLs that we have the function that we created. And as a result of our map, we want a data frame, right? A data frame that we construct by binding the rows. So that's basically map is the function, but we also talked in the video about the variants of map. And ultimately what we want is a data frame, not logical, not numeric, not character string. We want a data frame. So that's why we're using map DFR. Now, when I hit run here, it's going to take a second because what is happening? It's basically going to all 143, it looks like, links and going there, applying the function, grabbing the information, saving it as a tibble, doing it over and over and over 143 times. So that's why this is running for a while. Now, if this was a slightly more advanced course, things we would talk about would be, Could we maybe also put a progress bar here? So when you're waiting, you don't know, like, are things working or are they not working, right? So those are the sorts of things, if you're taking statistical computing later, you would be maybe talking about things like that. But for now, we're going to leave it here and not make things more complicated than they ought to be. If we wanted to add a 1 second gap, so it doesn't like constantly hit the server one after another, we can do so by adding assist sleep. So this into your function. So you would add it into your function. So before it goes, it sleeps for a little bit. And in fact, what we did in the videos we said is that instead of, usually you don't want to set a definite amount of time because sometimes websites don't like that, like behavior. So if you want it to be a random amount of time, you can say randomly generate one number for me and sleep for that many seconds. So what MapDFR does is it actually joins them all for you. So you don't have to do the joining yourself, which I think is a really sweet part of working with that, okay? That you actually don't need to do the joining. It will do the joining of the data frames for you. So it takes care of all of the bookkeeping. So now we have a data frame with some character columns and some list columns. And what we might do at this point, now that we have this data frame, is I'm going to save it, okay? Because I don't want to have to scrape the data again. I've scraped it once. From now on, I'm going to do an analysis on my data. I don't want to have to scrape it, okay? Any questions about the functions or this idea of running the function over multiple times? All right, so what I want to show you, so this next bit is just going to be a show as opposed to teach so much, because some of this will come back to when we do text analysis. But I wanted to give you a few things and give you some code for you to look through if you feel like it. So in the 5th file here, I have a fully functioning R Markdown document. I mean, hopefully we're going to knit it and make sure it works. But you can see that it starts by doing a few things. Loading the packages that we need. I went and looked up what the color blue is in the Scottish flag. Do people know how to do that? How you can figure out colors in a particular thing? So I'll show you one. Let's Google Scottish flag. And there may be other tools in other so if you actually like Google for Scottish flag blue, I think that on the Wikipedia page somewhere, it gives you the hex code for this. But there's another tool that you can use called digital color meter, at least in a Mac. There's a similar one in a PC as well. And you can hover over any color and it gives you the hex code for it. And so I save that hex code so my plots can be that blue, okay? It's just a way of not using the standard ggplot2 blues anymore. We talked about this last time when we did the code along, so our plots look a little bit nicer on the page. But more importantly, what I'm doing is I'm starting by reading that data frame, okay? I'm not going to scrape any more data. I already did it. I saved it in my data folder. I'm just going to use it here. So this, I don't mind knitting however many times I want because I'm not scraping data again. I'm simply using the data that I already scraped. So a few things that I did was to figure out what day of the week it is based on the date that we have saved. So it looks like Nicola Sturgeon did give some speeches on Sundays, but mostly she speaks on weekdays. And I guess she rests on a Saturday, I suppose. No speeches on Saturdays. I did a count of the number of words and number of paragraphs. And we'll talk more about what's going on here later on when we do text analysis. But if you want to take a look at it, you can. Usually it looks like she says about 2,000 words. But one thing that was interesting is that as the pandemic is sticking around, the speeches are getting longer and longer, it seems like. Like we're seeing somewhat of a positive trajectory. So here on the x-axis, we have the date. And on the y-axis, we have the number of words. And another thing I was curious about is initially everyone was talking about social distancing. And now we use the term physical distancing. So I tried to see, using this function called str_detect, which is also in the stringr package, was the word social dist. And you can see that I didn't say distance or distancing. I wasn't sure how she's going to use it in a sentence, but just social dist or physical dist. Does it exist in the over in each of the speeches? And here, basically, you can see that earlier in the pandemic, it was more social distancing. And then right around here, I don't know what that is, maybe around May, there were like, she's like starting to say maybe physical and social distancing together. And then from maybe June onwards, it's all physical distancing, and she doesn't say social distancing anymore. So we can see the pattern of change. And basically the key thing here for making this plot is this str_detect function that detects is a particular character string in a text field that you're looking at. Yeah, so it won't hit infinity because the journalists won't let it happen. They will ask questions, so it probably won't hit infinity. So here is some analysis of the text. But as I said, I don't, some of the code here, you might think, oh, we never learned this stuff, unlist, whatever. And you're absolutely right. So this is not to say this is what I expect you to be able to do right now, but this is a precursor to, once you start working with text data, what are the sorts of things you can do. What we want to focus on for this week is the web scraping aspect of it. So everything we did up to writing our data, and stuff like this should be things that you're a little bit more familiar with. Take a particular date, figure out which day of the week it is, and then make a bar plot. So str_detect is for detecting if a particular string exists. So it gives out a true or a false as a result. So if what you want to do is not to subset or to replace or to remove, but just to check, does it exist? That's when you would use str_detect. Any other questions? You're welcome. All right, so let me see if I can find, I'm not seeing any of my, I'll show you guys later. I have the comparison to the 10 Downing Street speeches. They're very different, turns out. They always use the word defeat, and she never says we'll defeat the virus. It's like an interesting thing to see. I like that she doesn't, because I don't like that sort of language, but it's like there are some stark differences between the speeches. Any other questions about this or about the homework or anything else? If it's about life, I'm not sure I can answer, but I'll answer things I know. Okay, so I hope that we resolved for the homework the issue of why is the R Markdown structure failing? And I hope that people are now familiar with how to check to see why it's failing, because that message is there for you. I've also now, like soon as we hang up, we'll fix the R Markdown knitting thing. And I'm going to push a change into your repository. So you may need to pull. So if it says you can't push, what you need to do is to pull. Because I'll make that change in your repositories so that you can actually see the check going through. Okay. All right, I'll stop recording now.